In analyzing a three-phase 208-volt electrical system, it's essential to understand the characteristics of the voltage waveform. The question posed involved examining two graphs to determine which accurately represents a 208-volt waveform and subsequently how many times the 208-volt value would appear in one complete cycle, considering both positive and negative instances. The analysis determined that both original graphs were inaccurate representations of a 208-volt 60 Hz sine wave. A correct representation would resemble a standard sine wave. In a single cycle of such a sine wave, the instantaneous voltage reaches 208 volts a total of 4 times. This occurs twice in the positive portion of the cycle as the voltage rises from 0 to its peak positive value and then falls back down, and twice in the negative portion of the cycle as the voltage decreases from 0 to its peak negative value and then rises back to 0. Understanding the frequency of a sine wave is also crucial. The frequency, measured in Hertz, indicates the number of complete cycles that occur in 1 second. In a 60 Hz system like the one mentioned, there are 60 complete cycles every second. So, the 208-volt value will occur 4 times per cycle, and this repetition happens 60 times per second. It is also important to note that the 208 volts refers to the root mean square, RMS voltage. The RMS voltage is a way of expressing an alternating voltage or current in terms of a direct current or voltage of equivalent heating effect. The peak voltage of the sine wave is higher than the RMS voltage. For a sinusoidal waveform, the peak voltage is equal to the RMS voltage multiplied by the square root of 2. Therefore, in a 208-volt system, the peak voltage would be approximately 294 volts. When analyzing electrical systems, it's vital to use accurate graphs and understand the relationship between RMS voltage, peak voltage, and the frequency of the sine wave to ensure proper calculations and prevent potential errors. The analysis provided gives the correct visualization and calculation and is helpful in the area of three-phase voltage analysis.